The problem I'm about to solve is how to calibrate a depth profile based on a peak model. I've chosen a very simple peak model. It's a silicon 2S, and I'm assuming that if I fit a single peak to the silicon 2S, I can identify a binding energy that's associated with the component. I've included another component to demonstrate the concept of the calibration based on the component in the first column. I've actually got two components. One is a linear background. This will be adjusted at the same time as this silicon 2P photo emission component, and the idea is that these two will adjust and produce a position that will identify the center of the silicon 2S photo emission, and therefore I can offset the spectra with respect to this component in terms of binding energy and therefore calibrate the silicon 2S. But the option I'm going to use is on the calibration property page that will apply by row first component. So this means that the first component on the components property page will be used to calculate the position, and I can specify, just for the sake of argument, I will set it at 150 eV, the true value for this component, and then if I apply by row first component, what will happen is that for each spectrum that is selected, the peak model that is fitted to that spectrum will deliver an energy, and that energy will be used to work out an offset that will be applied to the row for each one of these silicon 2S VAMAS blocks. So when I apply by row first component, what that means is I'm going to shift all of these data and all of these other data to align on a row by row basis. And there we go. There's the adjustment of the data. I did not adjust the regions and the components, so we can see that these components are left in the position that they were before the calibration occurred. But the data itself is now positioned, and it should be positioned at about 150, and yes it is. I'm doing that by eye. Similarly, we will see that the silicon 2P has all been aligned. The oxygen 1S and the carbon 1S, these are all now aligned. We can see they are aligned because they have an instruction that indicates that a calibration has occurred on the oxygen. We can also demonstrate the set of calibrated data by pressing the toolbar button that says select process blocks. The processing is the calibration, so if they don't all select, then I didn't do the job properly. So let's have a look again at the silicon 2S. The data's moved. I did not move the components, so these are left in their original position, but the calibrated data, by virtue of working out the offset between each one of these components and 150, has managed to align the silicon 2S.